I'm Sean.
I'm William.
And today our science project is about creating artificial gravity in space using centripetal force.
So to first understand what centripetal and centrifugal force, we're just going to have a look at the example of the Earth going around the Sun. So in this example, centripetal force is the force acting, is the gravitational force acting between the Earth and the Sun and pulling the Earth towards the Sun. And then what keeps it out is an equal and opposite force called the centrifugal force, which is caused by the centripetal force acting on the velocity.
So this is the experiment we used. We used a phone as the sensor to measure the velocity and a known radius measured with ruler. So can we create artificial gravity in space? We can, but there are a lot of problems such as motion sickness and fluctuations of gravity strength, which would affect the astronauts. The data was recorded from tuned phone positions 3 times each for more accurate results. And here we have the average of each experiment, which can be seen in the table.
So we then repeated the experiment because we found that there wasn't as big enough a change in the results because in the equation it's the mv squared over r. So we were expecting that the rate that the centripetal force would have halved when we halved the radius, but that wasn't the case. So we decided that we do a number of different values. I think we did seven different values, and we did 3 each to get an average of it. And then we found that we had a much more accurate result that showed that the radius was inversely proportional to the centripetal force. So as you can see here, that's graphed clearly, and then when we graphed centripetal force against 1 over radius, we saw that there was a straight line, and if you were to extend that, it would go straight through the origin, proving that the radius is inversely proportional to centripetal force.
Thanks for listening.
Thanks for listening.